Today we're going to review the very basics of logarithmic functions, or what we usually just call log functions. So let me start with an introduction. Really, the one most important thing to know about logs is that logs and exponentials are inverses. So basically, you might think to yourself, like, you might have learned logs before and thought they were real confusing and just kind of like memorized what to do. This number does this, and this number does that, and I switch this to that. But I really want you to understand what they are. So what logarithms are for is answering questions like this. If I asked you guys 2 to what power equals 75, a logarithm could answer that question. Now, first of all, just so you can see the relationship between a log and an exponential, if I took that question, I wrote it in words first, if I took it and changed it into an actual equation, it would look like this. 2 to what power means 2 to the x, solve for x basically, equals 75. That's called exponential form because it's 2 to the x. That's an exponential function. Now, I just want to mention to you guys, right here, we don't know the answer to this question. We could estimate just by knowing our powers of 2. You know, if I ran through my powers of 2 like this, if I said, okay, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, and 2 to the seventh would be 128. Now right there, I've passed up my number. 75 is between 64 and 128. So I know that the answer to this question is somewhere between 6 and 7. But I can't get much more accurate than that. It's, you know, the answer would be 6 point something as a decimal. Now a logarithm can answer that question very accurately. It can tell you, you know, to as many decimal places as you need, what that exponent needs to be, 6 point what, in order for 2 to that power to equal 75. All right. So here is what we call logarithmic form. I put y equals. I'm going to focus over here on the right, though. I'll focus right here. We have the word log for log, which is short for logarithm. Then we have a smaller subscript letter b, that's the base. And then we have a regular sized something, number or variable, x. Now, first of all, the way you would actually say that in words is you would say y equals the log base b of x. And I really want you guys to know that. I want you to be saying it right. Even if you're not saying it to somebody, if you're just reading it in your head, it's a good habit to start saying it right in your mind when you're reading it. So it's not log of b of x or log of b times x or anything like that. It's log base b of x. Now, here's what it's really asking you to do. If you have a question that says log base b of x, what it's really asking you is exactly like what we just did with the 2 and the 75. It's saying b to what power equals x. That's what logarithms really do. So it's saying whatever the base is, whatever this number is right here, to what power equals this one right here. Now, some of them you can do in your head without a calculator if it works out perfectly. Like if I asked you 2 to what power equals 4, we should be able to do that. But if I ask you 2 to what power equals 75, not so much. So let's try a couple that we can do without a calculator. So let's say no calculators here. We want to evaluate the log base 2 of 35. Now, in order to do that, you need to know what it's asking you to do. You know, if you just see the word log and a couple numbers and you just don't know what to do, then obviously you're not going to be able to answer that question. So remember what I told you on the last slide. If I ask you to evaluate a log, what this question is really asking you guys is 2 to what power equals 32? Or if you wanted to turn it into a question, into like an equation, you could say 2 to the x power equals 32. Or maybe instead of an x for this one, we'll put a question mark. Doesn't matter. Question mark x, same kind of concept. But that's what it's asking you. 2 to what power equals 32? Now we already ran through on the first slide our powers of 2. It's actually, the answer to this question is 5 because 2 to the 5th equals 32. That means the answer to the question, when I asked you to evaluate the log base 2 of 35, is just the number 5. It's asking you 2 to what power equals 32, and the answer to that question is 5. Okay, so let's evaluate the log base 4 of 0.25. And that one is asking you the question, 4, the base, to what power equals 0.25. Now you might be looking at this question thinking to yourself, that's not what I can do in my head. I don't know what 4 to what power equals 0.25. You actually do though, you just have to think of it in a slightly different way. So let's start with this. 4 to what power equals 0.25? And you look at it and your first instinct is like, I don't know. But let's realize that 0.25, if I wrote it as a fraction, that's 1/4. 0.25 is 1/4. Now if I rewrite the question that way, 4 to what power equals 1/4, now all of a sudden I'm using properties of exponents. Because a negative exponent does a reciprocal. So the answer to this question is actually -1. 4 to the -1 power turns 4 into its reciprocal, which is 1/4. So the exponent that we're looking for right here is -1. And that's the answer to the question. Log base 4 of 0.25 is -1. So there's 2 examples of log questions that you could do in your head. The first one was pretty straightforward because it was a whole number to answer. The second one shows how it can be a little bit tricky. You got to think, okay, that 0.25 is actually 1/4. It's going to be a negative exponent. The answer was -1. But if you think about my original question from today, 2 to what power equals 75, that would be the log base 2 of 75. And we still can't do that without a calculator. So we'll get to that actually not even today, a little bit later in the chapter. But just so you know, that's what a logarithm does. It's for answering questions where the variable is the exponent. Now let's go back to the fact that logs and exponentials are inverses. First of all, gotta have the same base. So like a 2 to the x and a log base 2 of x are inverses. A 7 to the x and a log base 7 of x are inverses. But if you mix them up, a 2 to the x and a log base 7 of x are completely unrelated. So as long as you have the same base, underline that, then logs and exponentials are inverses, and they cancel each other out. So for example, if I have the log base b of b to the x, so like right here on one side, I have a log base b, that's one function. And right here, the thing I'm taking the log of is b to the x. Well, as long as those b's are the same number, they're going to cancel each other out. The log part and the exponential part cancel out and leave just what the exponent was, which is x. And like any inverses, you can do it in either order. So if I did the exponential part first and the log part second, it also cancels out. So if I have some base b to the log base b of x power, then again the exponential part, which is here, that's on my b to the x function, the log part here, those two things essentially cancel out, and again just leave that x right there. So that's going to lead to our next example. One of the keys to being successful with logs and exponentials is being able to quickly and easily switch back and forth between the two. Meaning, like in certain problems, you may have a log function that you want written in exponential form, or vice versa. Maybe in another question, you have an exponential function that you want in log form. Understanding that relationship and being able to switch back and forth is very, very important. So we're going to do one of each. Let's start with this exponential equation, 5 to the x minus 2 equals 3, and let's change it to log form. And I'm going to show you two ways to do it. One way is a way a lot of teachers teach it, and it's more of a memorization trick. And then I'm going to show you one based on inverses that we just talked about. So let me show you the one that I think you've probably seen before. If we have, I'll recopy the question here. 5 to the x minus 2 equals 3. And I want to change that to a log equation. Then what you do is you start with the base, 5, and that becomes the base of your exponential. And then you do this, this is how some teachers teach it. It's kind of a circle pattern. You go from the 5 over here to the 3, and that goes here. Then the equal sign, and it goes back to the exponent there. It equals the exponent, x minus 2. So if that looks familiar to you, you probably have seen it from another teacher before, and it's fine as long as everything's perfect. As long as the exponential's in the right place and you don't have an extra number anywhere, things like that. But I'm going to show you a way that I think in the long run is going to be better for you guys. So let me recopy this question. We have 5 to the x minus 2 equals, and I'm going to leave a little bit of space. You'll see why in just a second. I'm going to put the 3 over here. All right, so this way, we're going to solve it more like we do for equations. We're going to solve it using inverses and canceling things out. So I'm going to say, okay, my exponential function in this problem is 5 to the x. If I want to cancel it, I'm going to use its inverse, which is log base 5 of x. So what I'm going to do for this problem is I'm going to take the log base 5 of both sides of the equation, which you're allowed to do. I mean, that's when you're solving equations, you can do anything you want as long as you do the same thing to both sides. Now over here on the right side, or sorry, on the left side, the log base 5 and the 5 to the x, remember that last slide? They kind of cancel each other out, and they just leave that exponent there, which is x minus 2. Now on the right-hand side, the log base 5 of 3, we're just going to leave. Now if you notice, even though it's flipped left and right, we have the exact same thing in light blue and purple. One of them is log base 5 of 3 equals x minus 2. The other is x minus 2 equals log base 5 of 3. So it's two different ways of doing the same thing. And you can pick the one that works better for you. But I'll tell you, as the questions start getting more and more difficult, the second method, it's going to be good for you to understand that, how to use inverses to cancel things out. So here's the other version of that question, the other direction, basically. So we have a log equation, log base 7 of 3x equals 2, and we're going to change it to exponential form. So let me show you both methods again, because I really do want you guys to see both. So let me recopy the question, log base 7 of 3x equals 2. And again, the first way to do it, if you want to change to an exponential, you start with the base. So the base of the log is 7. And that means the base of the exponential is also 7. And then you do that, that same little circle pattern. You go 7, here's going to be your exponent, 2, equals whatever was you were taking the log of, which is 3x. And we've done it. We've changed a logarithm into an exponential. Now let me show you the other way of doing this, using inverses. So let me recopy the question again. We have log base 7 of 3x equals 2. Now what I'm going to do for this, I'm going to look at this, I'm going to say, okay, I have a log base 7, which means I want to use an exponential base 7 to cancel that out. Now when I'm using an exponential base 7, what I'm essentially doing is I'm turning each side of the equation into the exponent. And I'm going to put this 7 right here, and basically say 7 to the log base 7 of 3x equals 7 to the 2 power, or 7 squared. Now, the 7 to the x and the log base 7 cancel, and just leave the 3x. And on the right-hand side, we have 7 squared. So the exact same thing happened twice in a row. The two sides of the equation are switched, which doesn't matter, but we got the same answer. One way or another, you get 3x equals 7 squared. So basically, again, you have two different ways of going at it here. You can use the little visual pattern. I'd say if you're going to do that, the little circle spinny trick, be very careful with it, because everything has to be in the exact right place. If you get two things moved and you try to do that circle trick, the numbers are in the wrong place. Now, if you're using inverses, that's more straightforward. You don't have to worry about where things are. That's going to work every single time, because inverses are how you truly solve equations, and logs and exponentials are our newest way to cancel out, just like multiplying and dividing or adding and subtracting. Okay, so let's talk about the natural log. In our last lesson on exponentials, we had the natural base e, and now we have the natural log. And it's related. Natural log just means log base e. So here's the thing. If you're ever in a question and you're thinking, okay, the base of this log is the number e, don't write log base e. Write ln of whatever, x or whatever it is. Now, ln stands for natural log. The reason it's ln instead of nl is because it comes from the Latin. It's something like Logarithmus naturale or something. But ln just means natural log. So just whenever you see ln from now on, even though the letters are switched because it comes from Latin, know that it means natural log. So if you're ever doing a question and you find yourself writing this, log base e of x, stop yourself. That should be a red flag to you. You should go, wait a minute, that's not a thing. If you write that, it's an incorrect notation, and you're probably going to lose a couple points for that. It's not like I'm going to mark the whole question wrong or something, but I would put a little x through it and put ln and say, no, that's not right. We're not supposed to say that. So if you ever find yourself writing log base e of x, just change it to ln of x. And we usually draw like script or handwriting ln for that. And then one other thing I want to mention, because this comes up every year, it is ln. I see all the time people write capital IN of x. It's not IN, it's ln, lowercase ln. So no INs, no log base e of x's. It's natural log ln of whatever x. And that also means that it's a new cancellation. So just like those questions we did, I'll make one up real quick. If I had e to the 5x plus 1 equals 17, and I asked you guys to switch that to log form, in order to cancel out an e to the x, you use a natural log of x. So you would take the natural log of both sides, and you would say natural log and e cancel each other out, and just leave the 5x plus 1, and it equals natural log of 17. So that's another version of the example we just did. If it's an e to the x or a natural log, then those two things cancel each other out. The only other one I would mention real quick is something called common log. Common log is base 10. And that's what you have if you ever see the word log with no base showing. So log base 10 of x, you don't need the 10. These are the only two logs we can do on the calculator so far. We will learn how to do other ones, but there's no button for like a log base 7 of x or a log base 3 of x. You have to do a little trick to get those. We'll learn very soon. But for right now, you have two buttons on your calculator. One of them probably says ln, and one of them just says the word log. That log button is base 10. Now, one thing I do want to mention, unlike natural log, this one here is actually okay to use. If you write log base e of x, that's an incorrect notation. If you write log base 10 of x, that's fine. The reason I want you to know this is if you ever see the word log, just log of x or log of 16 or log of 3y plus 1 with no base, then even though you don't see it, there's a 10 there. Now, if that seems weird to you, just think of it like square roots or like radicals. You know, if I write a cube root, that means it's the third root. And if I put a 5 here, that means it's a fifth root. Well, if I just put a square root by itself with no number, even though you don't see it, it means there's a 2 there because it's the common root. So it's the same thing with a log. The most common one used, we usually just don't even put the number there. And we just assume that it's a 2. Same thing up here. If you see the word log with no base, we assume it's base 10 because that's the most common one.